Welcome back. Let's take a look at another application of a multi-step equation. And we have the following word problem. A feed store laborer is dispensing fertilizer into bags to be delivered on a gooseneck trailer. The trailer is designed to hold 18 bags and will safely carry 20,000 pounds of cargoes. We're talking about a pretty big trailer here. Each empty bag weighs 8 pounds. How much weight should the laborer put in each bag in order to get the delivery weight as close as possible to 20,000 pounds? Okay, so we need to pick out our pertinent information here. So what's first? We have 18 bags. So 18 bags are what we're going to fill with fertilizer. Next thing is each bag weighs 8 pounds. 8 pounds. And this is the weight I'm struggling here, of an empty bag. 8 pounds is the weight of an empty bag. Okay, that's going to be important. All right, and next we have 20,000 pounds. 20,000 pounds, and this is the total maximum weight. So this is the amount of weight that we can't go over. So the total max weight. We don't want to go over 20,000 pounds because it can safely tow 20,000 pounds. Okay, so what are we asked to find? We're asked to find the unknown weight to put in each bag. So we'll call X, we're going to let X equal the weight of each full bag. So we're going to let X be the weight of a full bag. Now we have 18 bags that weigh 8 pounds each when they're empty. So when we're writing our equation here, we can start it with 18 times 8 because we're looking for the total weight that we're putting on this trailer. So 18 bags weigh 8 pounds apiece. Just when they're empty. So the actual bags weigh 8 pounds apiece. So we need to weigh that as well. We're going to fill all 18 bags with an unknown weight X, the weight of a full bag. So we're going to add 18X. 18 times X. Now these two quantities will combine to equal 20,000 pounds, or as close as possible to it. So we need these two to add up to as close to 20,000 pounds as possible without going over. All right, so now we have an equation to solve. So let's go ahead and get started. We can multiply 18 times 8. 18 times 8 is 144. We have our plus 18x and 20,000 on the other side. All right, we want the variable on one side and everything else on the other side, so we can go ahead and subtract both sides by 144. Line these up, make it a little easier. This one cancels, so we have 18x on the left side, and on the right side we have 19,856. And all we have left to do is divide by the coefficient to isolate the variable, because that'll cancel with that. And we do the same thing on the right side. That keeps the equation balanced. So we're left with x on the left side, and with a calculator we're just going to approximate this. This is approximately 1,103.11. So our laborer should fill each bag with an average weight of 1,103.11 pounds. Depending on how accurate the laborer's scale is, we may be rounding to the nearest pound. So we're not given this information, so we can leave this as our answer, but let's not forget our 3 checks. We have 3 checks. Do we want to know if the answer makes sense? Can we safely put a little over 1,000 pounds into 18 bags and it be close to 20,000 pounds? And we can see that 18 times 1,100 is just under 20,000 pounds, so yes, that makes sense. Now, does it solve our original equation? We can always check when we're working an equation by substituting the value that we found for x back into our original equation and make sure that it equals out. So if it does, then this is indeed our valid solution. Remember, this is approximated, so it might not be exact, but it should be within 2 decimal places. And the last thing I want to know is if our answer, it answers the question being asked. We're asked the question, how much weight should the laborer put in each bag in order to get the delivery weight as close to 20,000 pounds as possible? And yes, this actually answers the question being asked. Like I said in the previous example, that sometimes when we find, we solve a variable, it's not actually the end result. It's only a step to get to the end result. But in this case, it actually does solve the question being asked. We'll do another application of this in the next video. I'll see you soon.